honor to introduce to you Dr. Goldberg Elkhonon. He is a very famous scientist and on the brain, renowned for his clinical work, research, writing and teaching. And I like the fact that on the author book, the title of his book is The Executive Brain. So I always listen to him very carefully, and I'm not sure I understand everything totally, but I'm sure that we are going to try. And Mr. Goldberg, you have the floor.
Thank you. I think I want to trade spots with passion so I can control the words. Okay, I was asked to, I was sort of charged with a tall order to talk about executive functions, and I'll explain what they are, to talk about brain health, and to talk about gender-related issues, and to do it all in 15 minutes, right? So don't fault me if I fail. So, of course, neuroscience is a very rich and very large discipline, and historically it sort of proceeded bottom up. It started with the exploration of some of the more simple functions of the brain, and gradually it arrived at what we call executive functions. And these are very high-order mental functions in charge of decision-making, planning, mental flexibility, impulse control, foresight, and lofty things like that. These functions do have a laser pointer or something. Not really clear. These functions are mediated by the frontal lobes. This part of the brain, which I'm outlining with my hand, or maybe in the second outline will outline with a laser pointer. It's over there. You see it right there. Thank you. Yeah. It's your pen, I'm sorry. So, in any event,
but you can have it.
It's called the frontal lobes. Thank you. And this is the part of the brain in charge of these higher order functions which I just outlined. What do we know about the frontal lobes? We know that it's an almost uniquely human attribute. This diagram from one of my books shows the relative size of the frontal lobes relative to the rest of the brain, and you see how tiny it is in various simian species, in monkeys, even in apes, and then it surges exponentially in humans. And so it comes as no surprise that this part of the brain is indeed in charge of all these lofty functions. And as I said earlier, we refer to them, to these functions controlled by the frontal lobes, executive functions, and they include planning, mental flexibility, dealing with novel situations, dealing with situations which are characterized by uncertainty. Now the catch is that these functions are very slow to develop in normal development. They are not fully mature until a person is in his or her late 20s, maybe even early 30s. And they are also the first to succumb to the effects of aging. So as we age, they are the ones which decline first, both as measured by various cognitive tasks and also as measured by various neuroimaging techniques. As you look at the brain, look at which parts of the brain are characterized by atrophy, usually more than others, as part of a so-called normal aging process. It turns out that these frontal lobes are the ones to go first. Now, why this is so is an open question. We don't understand it. But a tantalizing possibility exists that this aging, very rapid aging of the frontal lobes is a flip side of the processes which we are now beginning to understand and which relate to neuroplasticity. Now, before I tell you about what neuroplasticity is and how it works and how it doesn't work when certain factors are lacking, let me just put a certain premise on the table, which is just a common sense premise. I would imagine that you will agree with me. That unless you are morphed into a dolphin or are transposed to the moon, as long as you inhabit a relatively stationary environment, as most of us do. As we age, the domain of the novelty shrinks and the domain of the familiar expands. Okay? As you age, you sort of master your environment. It becomes increasingly familiar. The kind of a range of totally novel situations declines. Right? We settle into routines. And that is, we don't have to be a neuroscientist to accept that. It's kind of a common sense argument. Right? Yeah. What I want to show you is that it is not necessarily a good thing. For that, I need to introduce the notion of neuroplasticity. What is neuroplasticity? Neuroplasticity is the ability of the brain to change under the influence of many factors, not the least under the influence of our experiences, under the influence of that which we actually do. And neuroplasticity is one of those transit terms. It's one of the terms du jour. So everybody talking about neuroplasticity. Not everybody understands what it is. In reality, it's a combination of various factors, so-called synaptogenesis, the ability of the contacts between the various neurons, nerve cells, to spurt and to grow, and to amplify, to proliferate. So-called angiogenesis, the ability of our brain vasculature to also grow. The small blood vessels which provide blood supply to various parts of the brain are not sort of carved in stone. They are subject to growth. They continue to grow through the lifespan to a large extent under the influence as a result of using our brain in certain ways. And various other factors, and particularly tantalizing possibility is that nerve cells, so-called neurons, may also continue to develop and grow through an increase in number through the lifespan, at least in certain parts of the brain. And that, incidentally, was something that was thought of as impossible until relatively recently. A very famous neuroscientist, Ramon y Cajal, got a Nobel Prize about 100 years ago by saying the opposite, by saying that it was impossible. And over the last maybe 20 or 30 years at most, data began to accumulate, basically upending this notion that the development of new neurons stopped at the age of maybe 2 or 3 years of age. And in fact, now we are becoming increasingly convinced that it continued through the lifespan. And what particularly intriguing is that these processes are governed to a very large extent by the extent and nature of our mental activities. Okay? So, of course, unlike the liver, our brain is a very heterogeneous system. Different parts of the brain are in charge of different mental functions. And depending on which mental functions you engage, the parts of the brains supporting these functions are the beneficiaries of these neuroplastic processes. Okay? Now, well, so and I just said, the slide says what I just said, neuroplasticity is anatomically specific. It benefits those brain regions which are engaged in your mental activities. Well, that's the good news. And here, I don't even expect you to read this illegible slide. Basically, it summarizes some data, and basically all this stuff is found in my books, and I'll tell you about it in a few minutes. This slide basically summarizes scientific evidence that these neuroplastic effects don't stop in young age, that they continue through the whole lifespan. Okay? Just very briefly, it appears that a certain part of the brain in charge of language is larger in people who speak more than one language. Certain parts of the brain in charge of musical discrimination is larger in musicians. Certain parts of the brain in charge of spatial memory is larger in those people who sort of have to navigate complex spatial kind of realms for a living, etc., etc. Now, the bottom line is a very interesting experiment conducted at the it's okay, I could just go. A few years ago, where a group of just randomly selected people, perhaps through an ad in some local newspaper, were recruited